Okay, so we have a good one here today from the UNSW integration B 2024, problem 8. We have the integral from 0 to 2024 factorial over the ceiling of 2024 minus x factorial times the floor of x factorial dx. Okay, when I was doing this one, I was thinking that almost for every integral, you've got multiple ways to do it. I think this is the integral where you just have one way to do it. I know someone's going to prove me wrong in the comments, but anyway, I'm just going to say this is the only method for this one, and we'll see how it goes. Okay, so to get started with this, I wanted this standard thing that I always do with the floor function, especially where we just have the floor of x. I want to break this up into like 2024 integrals or 2025 integrals, just breaking it up where the bounds are separated by 1. So for the first one, we're just going to integrate from 0 to 1. This is just going to be a constant here in the numerator. I'm going to leave it for now. I'm not going to factor it outside. And then here, between 0 and 1, the ceiling is going to round this up to 2024 factorial. You'll just notice at 1, this becomes 2023, but for every other value, we get rounded up to 2024. And then here for the floor of x, between 0 and 1, everything gets rounded down to just 0 factorial. Then for the next one, doing the same kind of thing, going from just 1 to 2, we get the same 2024 factorial. And then everything's just going to change by 1. So like between 1 and 2, this piece is going to become 2023 factorial. This is going to be 1 factorial. And then we'll just do one more over here. We're going from 2 to 3. So same thing. The floor rounds us down to this lower bound. So this is going to become 2 factorial. And this piece here will be 2022. And then actually, let's just do the last one. So the very last one at 2024, the upper bound is going to be 2024. And the lower bound is going to be 2023. And let's do this one out. So then for the floor of x, we round down to this value. So this value over here is going to be 2023 factorial. And then here for this part of 2024, this actually becomes 0. But for all other values, we're rounding up to 1 factorial. And now for this next part, I'm going to do something a little sneaky, and I'm just going to add one more integral. Now keep in mind, there's only one way to do this, so you have no choice but to do this step as well. So what I'm going to do here is we're going to add one more, just going from 2024 to 2025. And we'll just follow this exact same pattern, right, where we have 2024. Then for this piece, we're going to have our lower bound. This is going to become 2024 factorial, and this is going to be 0 factorial. I'm just doing it because I want to have that last term. Notice we have a 0 factorial here, and we end at 1 here. I want to have that symmetry where we get this all the way to 0 and all the way to 2024, just like this first case. But of course, by doing this, I've cheated and changed the whole integral, so I'm just going to subtract it off. So that way, we're just adding 0, so then this becomes allowed. So I'm just going to have an exact copy of this. And then at this point, just notice that what's in every single integral, there's no x. Everything is constants, right? We go through all this, so everything's constants. Doesn't matter which one, even these down here, it's just constants. So we can bring the constants out front of the integral. So when we bring everything out front of the integral, it turns out we're just integrating 1. So actually, it turns out for the integration part of this, every integral is going to be exactly the same. We're going to be we're just integrating 1 from like a to a plus 1, and that's going to be x. And when you evaluate this, what's going to happen for every integral? It's just going to be 1. So because every integral is going to be 1, we're just multiplying by 1 on every term. So essentially what's happening is all the integrals are going away. And so all that's happening is we're just summing up, or this is just going to be a summation of all these terms. So I can actually just rewrite this whole thing as a sum. Okay, so now that I've pushed everything together into a sum, what we have here, now keep in mind I added those 2 integrals at the end to create a 0. Well, one of them is going to be this one right here. And we had another copy of this that's just folded into this thing, because you'll notice when k is 2024, this here is 0, and this here is 2024. So at that case, where k is 2024, it's exactly identical to this right here. But then what I want to notice about this here, 0 factorial is just 1, so that goes away. But then I actually can just cancel this 2024 factorial with this one right here. So this whole expression here, this just becomes 1. So really all we need to do to finish this off is find some kind of numeric value for this sum right here. But now for this thing right here, you may recognize this is actually the same thing as just n choose k, in the case where our n value is going to be just 2024. And actually there is just a formula for this, so you could just use the formula and you're done at this point. But let me just show you where that formula comes from and how it works. Okay, so we have our formula for the binomial theorem right here on the board, and just notice this first thing, this piece right here. So this right here is actually exactly what we have in our problem that we want to find. And all we need here is just to know that our n value in our problem is going to be 2024. The same thing here with this n, that's going to be 2024. But the question is, what do we do with this a and b part, these exponentials over here? How are we going to get rid of that? Well, actually getting rid of this is going to be really easy, because all we need to do is if we set a equal to 1 and b equal to 1, then it doesn't matter what these exponents are, because 1 to any exponent is still going to just be 1. So doing it that way, this part goes away. What we have is exactly what we have in our problem. We found our a and b values. This is going to be just 1 plus 1. And of course, 1 plus 1 is 2. So what we're saying for this whole thing is just going to be 2 to the n, where n is 2024. And so we can just take this, plug it back in here. And so for our final solution of this, we just get 2 to the 2024 minus 1. Okay, there you have it. Good one from UNSW 2024. Thanks everyone for watching. Have a good day.